Hi guys, today we are going to learn about factoring linear expressions. You need to have out your purple book and please turn it to page number 259. Go ahead and pause while you get your book out, page 259 in your purple book. If you do not have your purple book today, then you need to use your spiral notebook or paper to write down the examples. We're not leaving to go get it. Okay, here we go. So today I can use the GCF to factor linear expressions. I can use the GCF to factor linear expressions. So a couple vocab words that we need to learn. First of all is monomial. That may be a new word to you. A monomial is just a number, a variable, or a product of a number and one or more variables. So let's look in your book in the square that says monomials. What do they already have? They have a 25. That's just a number. They have 2x. That's a number times a variable. Look at your other options and try and decide which ones would be monomials. Take a moment to think about that right now. So the first one that I see, negative 12, that would go in the category of monomial. It's just a number. 60x is a number times a variable. That would also be a monomial. 3/4 x minus 7, that has two terms. That is not a monomial. That would go over here. 2/3, negative 2/3 x, it's also a monomial. It's just a number times a variable. So we use that one. This one, last one, negative 6x plus 1/2, two terms, not a monomial. So your monomials, the key thing that you need to know is that it's one term only. So that's what we're going to be focused on today is those monomials and what we do with those. That's one term only. All right, so look down a little bit farther at the bottom. We are going to be factoring, and we did factoring before with prime factorization. And today we're finding the GCF, or the greatest common factor. That means that's the biggest number that goes into or divides into both of the other numbers. So let's just go ahead and do this one for 25 and 30 on your page. 25, remember we think what times what gives me 25? 5 times 5. Those are both prime, so I can circle them, 5 and 5. For 30, think what times what is 30? How about 5 times 6? 5 is prime, 6 can keep going. What multiplies to give you 6? 2 and 3, both of those are prime. Now, if I'm looking at these and I ask myself, what's the greatest common factor? Common means they both have it, greatest means the biggest. So let's look at what they have in common. I see a 5 and a 5. They do not have anything else that I've circled in common. So that's why we said the greatest common factor of the number is 5. Now, if we add to this 25x and 30xy, if I just put an x next to this and an xy next to the 30, then think about what else do they now have in common? They still have the 5, but they also have, they also have the x in common. Oops, I did the wrong one. The x in common. So that is why the answer for 25x and 30xy is 5x. Okay, let's try an example. I would like everyone to flip the page and go to the middle where it says check on page 260. On page 260. Find the GCF of 24a and 32a. So write 24a, 32a, give yourself a little bit of room, and let's do the factor tree. So 24. You can do this multiple ways. I'm going to go with 6 times 4. Those are not prime, so keep going. 3 times 2. 4, this would be 2 times 2. And then I still have an a, so I'm going to write down the a. For 32, I'll change colors for you. 32, let's do 4 times 8. Keep going with the 4. 2 times 2. Keep going with the 8. That's 4 times 2. And for the 4, 2 times 2. So if I'm looking now, and we still have an A, so I'll put an A down here and circle it. Now we're going to look at what they have in common. So look at both of them and kind of highlight or mark what is in common. I see 1, 2. I see a second 2. I see a third 2. And I see an A. So the GCF of 24A and 32A is going to be 2 times 2 times 2 times A. When I multiply that out, I'm going to get 8A. So that is the largest factor, the greatest factor that they both have in common. That can be divided into both 24A and 32A. Okay, go to page, what page am I on? 261 in the middle. I'm on page 261. I want you guys to try this one, 42xy and 14y. So you may want to pause and try to work it out. Okay, when you're done, come back. Here we go. This one would be 7 times 6, and then the 6 would be 2 times 3. 14 would be 2 times 7. This one also has a y. If I go back to my 42, it has an x and a y. Now, if I'm looking for what is in common, I see that they both have a 7. I see they both have a 2, and they both have a y. So all together, that gives it 7 times 2 times y, which is the same as 14y. So the GCF is 14y. Okay, so this is somewhat of a review, except for I know the variable part is new. Now we're going to go to the new part that is a little bit different. It's called factoring linear expressions. I would like you to skip all the way ahead to page 262 and the check at the very bottom. So when we are doing factoring, I want you to think of that kind of as reverse distributive. So when we distribute, we multiply. When we factor, we're going to divide. So we're doing factoring 6x plus 14. So we're going to say, what was this before we distributed? So step number 1 is you are going to find the GCF. So the GCF of 6x and 14. So I'm thinking to myself, what is the biggest number that goes into both 6x and 14? So you can do your factor trees or you can just think about it. The biggest number is 2. Step number 2, I'm going to take this 2 and put it out front. This is going to be what I'm multiplying by. I'm going to put parentheses like I'm about ready to distribute. And now I'm going to think 2 times what number would get me back to my original, which remember my original was 6x plus 14. So I am trying to think of 2 times what gives me 6x. That would be 2 times 3x plus 2 times what gives me 14. That would be 7. So my answer to this is 2 times the quantity 3x plus 7. Sometimes in algebra we want it multiplied, we want it distributed, and sometimes we want to leave it in its factored form. So this would be like reversing the distributive. We're going to practice some more of these. Skip ahead all the way until you get to the practice page, which is on page 265, and we're in the middle. 265 in the middle, number 7. On number 7, we look at the 5x and the 35, and you think, what is the GCF of 5x and 35? What is the biggest number that goes into both? That would be a 5. So you put a 5 here and then put your parentheses. Then you're going to think 5 times what gives me 5x? That would be 5 times x or 5 times 1x. 5 times what gives me positive 35? That would be plus 7. So this answer is 5 times the quantity x plus 7. If I distribute it, I can see that I get back to my original problem, and so I know I did it correctly. Let's look at the next one. I have 8x minus 14. What is the number that goes into both 8 and 14? The biggest number you can think of. That would be a 2. So I put my parentheses. 2 times what gives me 8x? 4x. 2 times what gives me negative 14? That would be negative 7. Here's a hint. If it starts with a negative right here, you're going to keep it negative. Okay? So that is your answer. So you should always have a number in the front, and then you should have your parentheses with what's inside. If you distribute and check it, you can see that you get back to the original problem. All right, let's look at the next one. We're looking at 3x and 11. Think to yourself, what goes into both 3x and 11? You probably can't think of anything other than 1. That's because both 3 and 11 are prime. So this one, we are going to write cannot be factored. If there's nothing that can be divided other than 1, you're going to write cannot be factored. And that sometimes is just your answer. All right, now I would like you to take your blue paper. You should have already done some of the problems where you were doing prime factorization and your factor trees. I would like you to turn it to the back side of it, and I would like you to do some problems here on the back side, factoring just like we did in our notes. Once you've had your blue paper checked, then you are going to be doing ALEKS 5.4 on factoring. It has both types of problems that we've done on this blue paper today. It has the factor tree problems, prime factorization, and it also has factoring with the GCF. So good luck, and do your best, and have a great day. Bye-bye.